Everyone, I hope you're doing well. Today we are gonna do something really interesting. I want to show you how you can simulate a heat exchanger system or a container in ESP Studio or Raspberry Pi Studio. Um, the heat exchanger system is basically could be used for many things, but assume you have a container of water and then you want to heat it with an element or a gas supply or something, and you want to understand how the temperature is being changed over time or affected. So without further ado, I'm going to go to the toolbar on the right side and create a radial input. So radial input is an input which is gonna kind of give you a way to enter a number into the system, like 0 to 100. And I'm gonna add a value to monitor its value. So let's go and connect these two, and I'm gonna set this like run. You see like there is 37%, and then the 37 is being printed or shown on the screen. What we want to do is we want to simulate a system like a kettle, for example, which has 2000 watts. So we need to interpolate this number from 0 to 100 to 0 to 250. And we are gonna kind of connect this value. Let's add another value so we can see this value as well. It is kind of interesting, actually. So when you interpolate the value, it just changes proportionally to the like 0, 100 will be mapped onto 0 and 2500. And yeah, we see the value here. I'm gonna stop the execution and go add heat exchanger container. So heat exchanger container is kind of complex system, but for this version we have, it is much more of a simulation rather than running it to that level. And I'm going to connect the value from the interpolation to a heat source, these three red connectors. And I'm going to latent heat value to 2400 for water, assuming we have 1 liters of water, a temperature of ambient 25, and then liquid temperature of 25, let's say. And the last thing I want to do is to put a gauge and kind of show that temperature inside the system. So when we like turn this on, we see that we have kind of like no changes to the temperature. Like basically there is no change to the temperature because there is no heating system, and the ambient temperature and liquid initial temperature are equal. So if I go and change the ambient temperature, or maybe like this one to 15, like liquid, and run it, you would see the temperature is rising slowly. This is because of like when you, very intuitive situation, when you put cold water outside, it just gets warmer, or much warmer water inside on your desk, it's just going to get colder over time. This is the same scenario being applied to like slowly getting temperature. But now if we set like to 2500 watts, and we will see like the temperature is rising much more faster. And if we reduce the power to like 500 watts, it still is rising, but definitely much slower. So I want to put this like into a bit like more, so it's gonna be more than 25 degrees. Let's say let it go up to, I don't know, 30, and then we shut it off. And from that point on, you see like it's going down slowly because the system actually thinks like there is no heating supply, and then like it reduces the power down. One more thing I like to show you. So if I had like 1000 liters of water, and then if I run this in the same temperature system, I set it to maximum, you will see probably it's gonna rise the temperature much more slowly. Like now you see like there is one I don't know, 1/100th of degrees increased. And yeah, practically we could write this information into disk and log it. and we could do some work on top of that. But this heat changer container is a really interesting module which will be more available for different scenarios. Now this is the desktop. If you have like web or on your Android, you could actually implement this very similar flow and run these simulations. Might be extremely useful. In the next versions, we will have the situation that you can connect this to a water source and drain system. Like these are the actual drain connectors, and then you could really run this without actual simulation or much more and better simulation here and there. Thank you for watching. I hope it's going to be useful for you. If you have any questions, comments, please write to me or put a comment below, and I will try to get back to you as soon as possible. Goodbye.